Hello and welcome to video number 6 in this series. In this video I'll go over the basics of numbers with integer exponents. So the number a with an exponent n means a times a times a n times. And here a is called the base, and that's any real number, and then n is the exponent, and that's an integer exponent. So for example, we could have 2 to the power 5, so that's going to be 2 times 2 times 2. So we're going to multiply 2 5 times. And if we evaluate that, that comes to 32. So a few more examples. Remember, the base can be any number. So it could be a fraction. So a half raised to the power 5 is a half times a half times a half 5 times. And so that's going to be 1 over 32. We could have a negative number as the base. So minus 2 to the power 5. So here we'll have minus 2 times minus 2 5 times. So the 2's, that will evaluate to 32 again. And then to figure out whether it's plus or minus, we have to figure out how many minuses we have. So if we have an even number of minuses, then we would have a positive result. But here we have an odd number of minuses. So we're going to have minus 32. The base can be any number, so it could even be an irrational number, like pi. So pi raised to the power 5, it's just pi times pi times pi times pi times pi. And I don't even know what that is as a decimal, but I'm not interested in that at this point. I'm just interested in knowing what that notation means. Pi raised to the power 5 just means pi multiplied by itself 5 times. Let's go through a couple of examples. So if I have a with an exponent of 1, that's just a by itself. So for example, 2 to the power 1 is just the number 2. So anything raised to the power 1 is just itself. A raised to the power 0 is defined as the number 1. So for example, 2 to the 0 is just the number 1. And this works for any real number for the base a. It can be a little bit tricky thinking about 0 to the power 0, but at least for some branches of mathematics, 0 raised to the power 0 is defined to be 1. We generally don't worry about that kind of thing, and we're normally working with bases other than 0, and so any base raised to the power 0 is 1. Now let's think about negative numbers as the exponents. So for example, let's start with a to the minus 1. So this is defined as the reciprocal of a. So for an example, 2 to the power minus 1 is 1 over 2. If I have any negative integer as the exponent, then that is defined as the reciprocal of a to the n. So for example, 2 to the minus 5 is 1 over 2 to the 5, and 2 to the 5 we calculated up here is 32, so that's 1 over 32. Here's a couple more examples with negative exponents. So I'm going to start with 1 over a, and then I'm going to have an exponent of minus 1. So remember what we did over here when I had a with an exponent of minus 1. It was the reciprocal of a. So this time I'm starting with the reciprocal of a, and I've got an exponent of minus 1. If I take the reciprocal of a reciprocal, I end up back with what I started with. So this is actually equal to a. So for example, a half to the power minus 1 is 2. And then just to push this one more step, let's start with 1 over a, and then raise it to the power of minus n. So we kind of have to look at what we did here and combine it with this idea of the reciprocal of a reciprocal is the thing itself. So we'll have a to the n. So an example is a half to the minus 5 equals, so the reciprocal of a half is 2, and we'll have 2 to the positive of the minus n, so 2 to the 5. A couple more examples. Let's do minus 2 to the minus 5. So that's going to be 1 over minus 2 to the 5. And minus 2 to the 5 was minus 32. So we're going to have 1 over minus 32, which is minus 1 over 32. And again, the base can be any real number. So it can be an irrational number like pi. So pi to the minus 5. That's going to be 1 over pi to the 5. We can also write this as 1 over pi to the 5, like that. Let's explore a few more complicated expressions involving exponents. So let's start with a b and then an a to the n. So we're multiplying b by a to the n. So we just have to be a little bit careful with the order of operations here. So as an example, let's do b is 3 and a is 2. And let's have n be 5. So this is equal to 3 times 2 to the 5. And 2 to the 5, that's an example we did earlier, that's 32. So 3 times 32, which is 96. You've got to be a little bit careful here that you're not going to try and do the 3 times 2 first and then raise it to the power of 5, because that's a different thing entirely. Because that's going to be 6 raised to the power 5. So 6 times 6 times 6, 5 times. It's going to be a lot bigger than 96. What about b times a to the minus n. So remember, a to the minus n was over here. That's 1 over a to the n. So we could rewrite this as b over a to the n. So an example here would be if b is 3 and a is 2 and n is 5. So we're going to have 3 divided by 32. And one last example, let's do b divided by a to the minus n. So we could think of this as b times 1 over a to the minus n. Because I've got a to the minus n in the denominator. And the reason I've written it like this is that I can match it up with something we did earlier. We've got 1 over a to the minus n is the same as a to the n. So this is actually the same as b times a to the n. And so these two expressions are equivalent. So pause the video at this point and see if you can figure out what the next two expressions look like if you evaluate them and simplify them as far as possible. So for the first one, we're going to have 4 times minus 2, and the minus 2 is raised to the power of minus 3. And for the second one, let's do minus 3 divided by minus 4 to the power minus 2. So there's a lot of things going on here. So you're going to have to put together things that we reviewed earlier to figure out what these two expressions evaluate to. So for the first one, we've got a negative exponent in the numerator. Like, we don't have a denominator here. There's no fraction here. There's nothing in the denominator. It's all in the numerator. So we've got minus 3 in the numerator. So let's go back over here and see what we have to do when we have a negative exponent in the numerator. So we're kind of in this situation here. We've got something with a negative exponent. So that we can rewrite that as 1 divided by the thing a, whatever that is. In this case, it's going to be minus 2, with now a positive exponent. But we have to put it in the denominator to do that. So let's do that. We'll leave the 4 in the numerator. And now in the denominator, because now I'm turning this into a fraction, I'm going to have minus 2. The minus 2 is raised to the power of the positive of this, what is currently a negative integer. So 3. So that's going to be 4 divided by minus 2 raised to the power 3. Minus 2 raised to the power 3 is just minus 2 times minus 2 times minus 2, which is minus 8. So we're going to have 4 over minus 8, and that is not in lowest terms. We've got to reduce this to lowest terms. There's a common factor of 4 in numerator and denominator. So this is going to be equal to minus 1/2. For this one, I'm starting off with a fraction where in the denominator I've got something with a negative exponent. So we're in this situation. I've got something in the denominator with a negative exponent. And if that's the case, I can rewrite this by putting the thing that's in the denominator in the numerator with the positive of that negative exponent. So I'll keep the minus 3, and then I'll move the minus 4 to the numerator, and then the negative exponent now becomes a positive exponent. So we're going to have minus 3 times minus 4 squared. Minus 4 squared is positive 16, because it's minus 4 times minus 4. The two minuses kind of balance each other out. We get positive 16. Positive 16 times minus 3 will now be minus 48. So these two examples, everything that we've done up to this point in this video series, this is starting to get a little bit hairy now. But if you just go through each step, step by step, applying what we've learned, you should be able to make sense of these two examples. So if you tried to do these and you couldn't quite get there, maybe review the video again and review what we did here. What I'm looking to do here, kind of big picture, is anytime I see a negative exponent, those are difficult to deal with. And so ideally what you want to do is you want to get rid of those negative exponents, turn them into positive ones by either moving something that's in the numerator, like this, into the denominator, and switching the minus 3 to a plus 3, or vice versa, moving something that's in the denominator with a negative, moving it into the numerator with a positive. So that's how to deal with negative exponents. You kind of switch them, move them either up or down, and change the negative exponent into a positive one, and then you can do the evaluation. So that's it for this video. In the next video, we're going to continue working with numbers with exponents, but we're going to start to use arithmetic with them.